Okay, so let's say for our next example, if we wanted to solve 5 plus 4 over x equals 1. Okay, so first step, we only have one denominator, so we don't have to worry about factoring. I mean, we don't have anything to factor except 4. You can make it 2 times 2 if you want to, but it's not really necessary. Okay, so factoring is not necessary. Okay, so you can skip step 1. Okay. Now our second step, we want to match our denominators. Now really, when you have whole numbers, those are the easiest ones to use, or easiest problems to solve, because coming up with the least common denominator is really quick. All you have to do is remember that since this denominator is x, that 5 is just equal to 5x over x. You cancel out the x's, you just end up with 5. And 1, that's just x over x. So all you have to do is replace all of those. So instead of 5, we'll have 5x over x plus 4 over x equals x over x. You can say 1x over x if you want to, but it's not really necessary. Okay, and again, if we multiply each term by the least common denominator, which in this case is x, they'll all cancel out. Okay, so if we have x times 5x over x plus x times 4 over x equals x times x over x. Okay, so these two will cancel out, those two will cancel out, and those two will cancel out. Okay, which leaves you with 5x plus 4 equals x. So here, once you have the same denominator across both sides of the equal sign, these will just cancel out. So that's why we're left with just our numerator. So this step here, you can really skip it once you match all the denominators. Okay, so now brings us to our third step, which is just to solve it. Okay, so we go ahead and subtract x from both sides. So we have 5x minus x, so we have 4x plus 4 equals 0. So now we subtract 4 from both sides. Those two cancel out. So we have 4x equals negative 4. Divide both sides by 4. And we have x equals negative 1. Okay, which brings us to our fourth step, which is to check to make sure none of our denominators equal 0. And again, most of the time you can just look right up your problem. Okay, yeah, that's good, and go right on to the next one. So if you have 5 plus 4 over x equals 1, if you plug in negative 1, that denominator is just negative 1, so you're good. Make sure that's filled in there. So you know this is a valid solution. Okay, so we know that plugging in x equals negative 1 will not cause the denominator equal 0. I'm going to cause any denominators to equal 0. Yes.
So if sometimes they ask in the exam that if there's a solution, if is equal 0, so there's no solution, right?
Yep, it would be no solution. Okay, so let's say if we have, I'll leave that up for a few more seconds, make sure everybody got it. Looks like. Okay, so let's say, for example, we wanted to solve 1 over x plus 2 equals 4 over x squared minus 4 minus 1 over x minus 2. Okay, so your first step, you want to factor everything that needs to be factored. Okay, so the only thing that can actually be factored is this term here. And that's because it's a difference of squares. Okay, so you know difference of squares, a squared minus b squared is a plus b times a minus b. So x squared minus 4, we can rewrite that as x squared minus 2 squared. Your a is equal to x, and your b is equal to 2. So that will be x plus 2 times x minus 2. Okay, so we can rewrite that as 1 over x plus 2 equals 4 over x plus 2 times x minus 2 minus 1 over x minus 2. And I'll go ahead and put parentheses there. The first thing we notice is that we're missing some denominator pieces on some of those terms. So we have an x plus 2 here, and x plus 2 here, but we don't have an x plus 2 there. So that's missing an x plus 2. You have an x minus 2 here and an x minus 2 there, but this one's missing our x minus 2. Which brings us to our second step of matching the denominators. Okay, so that means if we're missing an x minus 2 here, our 1 over x plus 2, we're just going to multiply that by x minus 2 over x minus 2. Okay, so that equals 4 over x plus 2 times x minus 2 minus 1 over x minus 2. That's missing an x plus 2. So it's times x plus 2 over x plus 2. Okay, so now all of our denominators match on both sides of the equal sign. But if you remember, if you multiply every term by the least common denominator, all those denominators will cancel out. So if you multiply each one by x minus 2x plus 2, they'd all cancel out. So it would just leave your numerators. Okay, so that leaves us with 1 times x minus 2 You don't have to write the 1 if you don't want to. Equals 4 minus 1 times x plus 2. Which brings us to our third step, which is just to solve. Okay, so distributing the 1s and negative 1s, we have x minus 2 equals 4. Negative 1 times x is negative x. Negative 1 times positive 2 is negative 2. So x minus 2 equals 4 minus x minus 2. So we can go ahead and combine those two terms. So x minus 2 equals 4 minus 2 is 2 minus x. So if we go ahead and add x to both sides, those two cancel out. So x plus x, so we have 2x minus 2 equals 2. Move that over a little. So if we add 2 to both sides, where those two would cancel out, we have 2x equals 4, where if we divide both sides by 2, we have x equals 2. So now we go to our last step, which is the check. And most of you probably already looked up and noticed, instead of x squared minus 4, we'll use the x plus 2, x minus 2, since it's the same thing, minus 1 over x minus 2. Okay, so if you plug in x equals 2, it doesn't have to be all of them. It just takes one undefined fraction where you have a 0 in the denominator. So if you plug in x equals 2, actually these two will both be undefined. Okay, so we know that plugging in x equals 2 will cause a denominator equals 0. Okay, so we actually know we can't use that. That's not valid, or not a valid solution. Okay, so in this case, there's actually no solution. Okay. So on the test, they will actually say, okay, x equals 2 is your answer. If you marked in x equals 2, it would be wrong. So that's why you always want to make sure you don't have a denominator equals 0. Yes.
Okay, so what if so you plug in that 2
Mm-hmm.
in the x plus 2,
Mm-hmm.
you know, on the far left.
Yeah.
1 over x plus 2, that would be 4, right?
Yep, so this one's good.
That one's good.
Yep, this one's good. It doesn't have to be all of them. It just takes one. If you have one denominator of 0,
one of them
yep,
is bad.
just one. Yep.
Oh,
Yep. You can have 3 or 4 that are just fine, but if you have that one that's not, that's all it takes.
If one is 0, so it's only multiply with all becomes 0, right?
Well, they won't all become 0. It's just that one undefined fraction means you can't solve it.
Oh,
That's all. All right. Any other questions on this one? All right. I'll leave that up for a few more seconds. Excuse me. All right, looks like everyone's done writing. Okay, so what if we wanted to solve 3 over x plus 3 equals 12x plus 19 over x squared plus 7x plus 12 minus 5 over x plus 4. Nope. Straighten it. All right, so our first step is we factor whatever can be factored. Okay, so 3 and x over 3, neither one of those can be factored. 12x plus 19, they don't have anything in common, so you don't have to worry about factoring that one. The only one you have to worry about factoring is the trinomial. Okay, so we have x squared plus 7x plus 12. Okay, so there's nothing in front of the x squared, so we can use the direct method to factor. So our b is equal to 7, and our c is equal to 12. We just have to find two numbers that multiply to equal our c, and those same two numbers add to equal our b. Okay, so for this one, 4 and 3 works. 4 times 3, and 4 plus 3. Okay, so that means this will factor into x plus 4 times x plus 3. Okay, so we can go ahead and rewrite that using our factor denominator. And let me bring that down a little bit since it's going to run into my little box there. Actually, I have enough room. I can just rewrite it. So 3 over x plus 3 equals 12x plus 19 over x plus 4 times x plus 3. Minus 5 over x plus 4. And put a little parentheses around that one. Okay. So we can already see that our denominators don't match. We have an x plus 4 here and an x plus 4 there, but this one's missing an x plus 4. Okay. So we have an x plus 3 here and an x plus 3 here, but this one's missing our x plus 3. Which brings us to our second step, where we match our denominators. Okay, so we know if this one's missing the x plus 4, we have 3 over x plus 3 times x plus 4 over x plus 4. Equals 12x plus 19 over x plus 4 times x plus 3, bless you, minus, this one's missing the x plus 3, so that means our 5 over x plus 4 is going to be multiplied by x plus 3 over x plus 3. So all of our denominators match. And once they match, they all cancel out. Because we multiply them all by x plus 4 times x plus 3, they'll cancel each other out. Okay, so we're left with 3 times x plus 4 equals 12x plus 19 minus 5 times x plus 3. Which brings us to our last step of just solving it. Okay, so we get rid of all of our parentheses by distributing. Okay, so we have 3 times x, which is 3x. And 3 times positive 4, which is 12. equals 12x plus 19. Negative 5 times x is minus 5x. And negative 5 times 3 is minus 15. And we can go ahead and combine like terms. We can combine those two and those two. Okay, so that leaves us with 3x plus 12 equals 12x minus 5x is 7x. And 19 minus 15 is 4. So you can subtract 3x or you can subtract 7x. Doesn't matter. I'd probably just subtract the 3x just to keep this from being a negative number. But it will work either way. Okay, so you have 12 equals 7x minus 3x is 4x. Oop, plus 4. I'm jumping ahead there. So now we subtract 4 from both sides, where those two cancel out. So you have 8 equals 4x. And again, we divide both sides by 4. We end up with x equals 2. So for our fourth step, we just check it again. And most of you already figured out probably that this one's good, because you have 3 over x plus 3 equals 12x plus 19. Instead of x squared plus 7x plus 12, I'm going to leave it as x plus 4, x plus 3, minus 5 over x plus 4. So plugging in x equals 2 will be okay. None of those denominators turn to 0. Okay, so this is actually a valid solution. Okay, and that's because x equals 2 will not cause any denominators to equal 0. All right, so any questions on that one? All right. Leave that up for a few seconds. So let's say we wanted to solve x plus 14 over x minus 2 equals 7x over x minus 2 plus 1. So looking at it, all numerators and denominators are about as factored as we need them to be. So first step, no factoring necessary. Okay. Now for our second step, we're going to match our denominators. And again, you have those single terms. Since our only denominator is x minus 2, we can easily make all of those match. You just have to remember that x, you can make that equal x times x minus 2 over x minus 2. So if you cross those x minus 2's out, you're left with x. And 1, we can make 1 equal anything, so that could be x minus 2 over x minus 2. Okay, so now we have x minus 2's in the denominator all the way across. Okay, so x, remember that's just x times x minus 2 over x minus 2 plus 14 over x minus 2 equals 7x over x minus 2 plus, and instead of 1, we just make that x minus 2 over x minus 2. Okay, so we have the same denominator, both sides of the equal sign. When they're the same on both sides of the equal sign, they just cancel each other out, which leaves us just the denominators. Okay, so we have x times x minus 2 plus 14 equals 7x plus x minus 2. Okay, so now comes our third step, which is just to solve. So if we distribute the x there, and here you can distribute a 1 if you want to, or just drop the parentheses. You have x squared minus 2x plus 14 equals 7x plus x minus 2. Okay. Now you can't factor this because it has to be equal to 0. So you have to move everything to one side. So if we go ahead and combine those two, that's x squared minus 2x plus 14 equals 8x minus 2. So now we can go ahead and subtract 8x from both sides. Okay, so you have x squared minus 10x plus 14 equals negative 2. So now we can just add 2 to both sides. So we have x squared minus 10x, 14 plus 2 is plus 16 equals 0. Okay, so now that we have our trinomial equal to 0, now we can factor it. Okay, so we know our b is equal to negative 10, and our c is equal to 16. Okay, so we have to find two numbers that multiply to equal 16, and those same two numbers add to equal negative 10. Okay, so we know by this being positive and this being negative, the numbers you multiply would have to both be negative. So in this case, negative 8 and negative 2 works because it multiplied to equal positive 16 and add to equal negative 10. So that means this will now become x minus 8 and x minus 2. So you have x minus 8 times x minus 2 equals 0. And I'll bring this up here because it's only a few little steps left. Okay, so if you have x minus 8 and x minus 2, anything times 0 will be 0. It doesn't matter what it is. So if you make this factor 0, 0 times whatever this is, it doesn't matter because it's just going to be 0. Or if you make this equal 0, 0 times whatever that is, it doesn't matter, it's going to equal 0. So that means, in this case, x minus 8 can equal 0, or x minus 2 can equal 0. Either one of those would make that true. So that means for this one, if you add 8 to both sides, that means x can equal 8, or if you add 2 to both sides here, x can equal 2. Either one of those would make this one true. So that means we have to actually check both of them. Okay, so we know we